This video runs through the solution for 2014 sample paper 2, question 9. So in this question we're given a diagram with a man standing next to a container, and we are asked in the first part of the question to estimate the height of an average adult man. Now, because we're being asked to estimate, they're not going to hold us to an exact value, and any reasonable value will be accepted. So in the back of the papers, they give you a solution of 1.8 meters for this, but you've got a little bit of give and take. You could say anywhere really between about 1.7 and 2.1 meters and you'd be accepted. Note that even if you choose an unrealistic value, you won't be penalised in the rest of the question, provided what you do makes sense for that number. I'll stick with our estimate of 1.8 meters. And if we just look at the image of the man, we'll see that in this diagram, he's 6 boxes tall. So we can divide 6 nicely into 1.8. So we can take it from this point on that each box is a distance of 0.3 meters along the side. And this allows us then to approach part B, which asks us to estimate the dimensions of the tank. We're asked to write our answers for this onto the diagram. So at the top, it goes across 8 boxes. So we'll have to multiply 8 by whatever we've decided that one box is. We've decided 0.3, so 0.3 by 8 is 2.4 meters. Looking down the right-hand side, I can see that I'm approximately looking at a distance of 3 boxes here. So 3 times that 0.3 gives me 0.9 meters. The next section is roughly 9 boxes in length. So 9 times that 0.3 gives us about 2.7 meters. And this last section here is about 5 boxes. So again, 0.3 by 5, which is 1.5 meters. In part C of the question, they ask us to find the capacity of the tank, and capacity just means volume. They point out to us in the question that we should treat, my God, if I could spell, that should be cylinder, where's my D? That we've got cylinders and cones, so I'm going to write down their formulae, pi r squared h and 1/3 pi r squared h. And then I have to just have a think for a second about what the radius of the cylinder and the cone should be and what their height should be. So thinking about the cylinder first of all, I've written down my formula with blanks for radius and height. The cylinder is this section here in the centre, and its radius will be halfway across the cylinder. So from the centre out to the side. Now, I already know that the full distance across is 2.4 meters, so the radius must be half of that, which is 1.2 meters. So I'll fill that in for radius. And again, looking at the diagram, the height of the cylinder is this distance here, which I've estimated at 2.7 meters previously. So I'll fill in 2.7 meters there for the height. And then off I go to the calculator to work that out. And the volume of the cylinder is approximately 12.21 meters cubed. There's 2 cones, so I've labelled them cone 1 and cone 2. I already have the formula for cone noted, 1/3 pi r squared h, and I'd really strongly advise you to write those formulae down before you fill anything into them. So looking at cone 1, I need to know its radius. Okay, so it's sitting perfectly on top of that cylinder, so it must have the same radius. So I can fill in my 1.2 there. And I can see that I've estimated its height at 0.9. So 0.9 is going to get filled in there. And then off to the calculator to get the solution for that. And it's got an approximate volume of 1.36 meters cubed. On I go to cone 2, which is this one down here at the bottom. Again, I'll write out the formula with spaces for the values. And I can see again that the radius of cone 2 must be the same as the cylinder because it fits onto it perfectly. So 1.2 can go in there. And this time the estimate for the height was 1.5. And again, calculator time to get the value for that. And that cone's volume comes out as 2.26 meters cubed. To get the total capacity then, I must simply add up the volumes of each of the individual shapes. When I add those together, I get 15.83 meters cubed as my total capacity for the tank. Do make sure in these kind of questions that you include your units, because if you haven't got the units in, you are at risk of losing marks.